Hello, this is Schedulytics. Welcome to today's session. In today's brief video, we're looking at the concept of one sample t-test. We will demonstrate this using JASP, and as we do, we would appreciate the use of one sample t-test when it comes to inferential statistics. Are you aware that one sample t-test is based on some assumptions? Well, if you watch this video to the very end, you will be able to know about these assumptions. So we encourage you to watch this video right to the very end so as to know about these assumptions. Now, one sample t-test, what is it all about? Well, it is used to ascertain whether or not the sample mean is statistically different from a known or a hypothesized population mean. So for example, we are looking at height. Now let's assume that it is hypothesized that in a population, the mean height of the people is, for example, 1.2 meters. Now we sample a section of this population, we take their height, and then we measure the mean height of that particular sample. Now, maybe we realize that is 0.8 meters. Now, comparing 0.8 meters to 1.2 meters, is there a difference? That is where one sample t-test comes in, to be able to tell if there's a difference between the sample mean and the hypothesized population mean. Now, there is a null hypothesis that is always tested for whenever we are undertaking one sample t-test. And that null hypothesis is that the sample mean is equal to the population mean. So this is the null hypothesis. And so when our p-value is statistically significant, then we reject this null hypothesis. Now, what are some assumptions that are made when we're trying to consider one sample t-test? One of them is that the test variable that we intend to use to calculate a one sample t-test should be a continuous data set. The second assumption is that the test variable data should be independent. That is to say, there should be no relationship between any of the data points. Another assumption is that the data should be appropriately or approximately normally distributed. Now, if you want to know how to tell if a data set is normally distributed, you may want to read or watch our video on normality testing in the channel. Now, the last assumption that is made is that there should be no significant outliers in the data set that you intend to use to calculate your one sample t-test. Now, having established these facts, we now want to practicalize this using JASP. And so let's flip to JASP and continue from there. Good, so now we are on the JASP platform, and we, as usual, will click here and open the data library, and then we'll go to t-test, and then we'll try to look for the data set, the sample data set that we can use to demonstrate one sample t-test. This one says independent sample t-test. We can't use that. This one is also independent. We can't use that. This is also independent. We can't use this as well. This is paired sample t-test. We can't use this. Now, when we come here, we realize this is one sample t-test. So this is an excellent example we can use. And it's a data on weight gain. So we click on it and it loads the data. This is a brief description of the data. It says weight gain, one sample t-test. The description, this data set weight gain provides weights of 16 participants before and after an 8-week period of excessive calorie intake. And this is getting obtained from the reference is there. Now, when we take a careful look at this, it says that this example JASP file demonstrate the use of one sample t-test. We would test, notice the hypothesis that 1,000 excess calorie intake per day over 8 weeks result in 16 pounds weight increase. So you realize that the mean increase in weight is 16 here. So we are going to test our sample mean against this hypothesized or known mean weight gain. Now let's go. Now, when we click on descriptive statistic, first we want to check to see if some of the assumptions or all the assumptions that we have mentioned are all in place. Then we can proceed. First, this data set is a continuous data. Why? Because weight is a continuous variable. So our first assumption is taken care of. Second is that it should be independent, or the data points should be independent of each other. And these are 16 different individuals, so the data points are also different from each other. Second assumption checked. Now, a third one has to do with whether it's normally distributed or not. So what we are going to do is that we'll click on statistics and check on the Shapiro-Wilk normality test. And then we'll look at the p-value. Now, it says that the p-value of Shapiro-Wilk's normality testing is 0.33. And 0.33 is greater than 0.0005. So this means that this is not statistically or significantly different from the normally distributed data. And since it is not normally different, since it is not statistically different or significantly different from a normally distributed data, we can conclude that this data is normally distributed. So it has equally passed the third assumption. Now, a data that doesn't have outliers would mean that it is basically normally distributed. And so the fourth assumption is equally catered for to some extent. Now we move to the one sample t-test, which we are much focused on. Now, we realize that the p-value calculated is less than 0.001. And from our studies, this is less than 0.05. Hence, this is statistically significant. The sample mean is what? 10.41. Now, when we come to the interpretation of these results here, it says that the results indicate that the data are very unlikely to arise if the mean gain of weight in the population was this, that is 16 pounds. We can thus reject the null hypothesis. So the null hypothesis, as we established, is that the mean of the sample is equal to the mean of the population. But in this regard, the mean of the sample is 10.41, and that of the assumed population is 16 pounds. And so we can accept the null hypothesis that the sample mean and the population mean are equal. I hope we are able to understand the concept of one sample t-test and how we applied it using a test sample in the JAS platform. Now, in case you have your personal data and you intend to undertake one sample t-test, what you do is that you click on this button here, t-test. Once you click on it, you have opportunity to select one sample t-test, and then you have this drop-down menu or interface created for you to select the variables that you'll be using to calculate your values. So briefly, we've been able to look at one sample t-test, demonstrated it using JAS, and saw its use in statistics. This is Schedulytics. Until we meet again, we would always encourage you to like the video, to share, and to subscribe. Until we meet again, as usual, it's a bye.